So, how do you manage something you can't see? I mean, really think about that for a second. In software engineering, that's the core problem we face every single day. Unlike building a bridge or a car, our product is, well, it's invisible. You can't just kick the tires on a piece of software to see if it's well made. So, how do we get out of the realm of just guesswork and into real, solid engineering? Well, the answer, as we're about to see, is all about measurement. The whole trick is making that invisible thing visible. And we do that with a really powerful tool set, software metrics. So in this explainer, we're going to break down exactly how we use them to measure, to understand, and ultimately to improve the software we all build. All right, here's our game plan. We're going to start with the big why. Why even bother measuring software? Then we'll get our definitions straight so we're all on the same page. After that, we'll look at the different ways to slice and dice metrics, tackle a classic apples-to-apples problem, and wrap up by figuring out what actually makes a metric good versus just noise. Okay, let's dive right in. Why measure? To put it bluntly, you can't really call what you're doing engineering if you're not measuring anything. Measurement is the secret sauce that takes the art of coding and turns it into a predictable, manageable discipline. And the reasons for doing it are super practical. I mean, we're talking about getting a real number for quality instead of just relying on a gut feeling. It's about building a baseline so our next project estimate isn't just a shot in the dark. It even gives us the cold, hard data we need to go to our boss and say, hey, if we invest in this new tool, it's going to make us X% more efficient. It's powerful stuff. All right, before we go any further, we've got to get our vocabulary straight. We're about to throw around a few words that sound kind of similar, but have some really important differences. So let's lock in these foundational terms right now. First up, a measure. This is as simple as it gets. It's the raw number, the direct count. For example, we found 342 errors. That's it. That's a measure, a single data point. And measurement? Well, that's just the act of getting that number. It's the process you went through to do the counting. Simple as that. Now here's the most important one, the metric. A metric is where a raw measure gets its meaning, its context. It's not just 342 errors, it's 2.4 errors per 1,000 lines of code. See the difference? That context turns a simple number into a powerful insight we can actually use to compare things. And finally, an indicator. Think of an indicator as a metric that's basically waving a flag at you. If that metric of errors per 1,000 lines of code suddenly doubles this month, well, that's a huge indicator that something in your process just broke, and you need to pay attention to it, like right now. Awesome. So now that we have our vocabulary down, let's put it into practice. You can think about software development through 3 totally different lenses: the overall process, the specific project you're on, and the actual product you're building. And each one needs its own special set of metrics. Here's an easy way to think about it. Process metrics are about the long game. How can we get better across the next 5 projects? Project metrics are all about the here and now. Are we on track for this release? And product metrics, well, they look at the code itself. Is it getting too complex? Is the quality high? 3 different jobs, 3 different types of metrics. Now, let's look at a classic problem that shows exactly why metrics are so much more useful than just raw measures. We'll call it the tale of 2 teams. Okay, on the surface, this looks pretty straightforward. Team A found 342 errors before their software went out the door. Team B, on the other hand, only found 184. Those are our raw measures. So, the big question is, which team did a better job? I mean, your gut probably screams Team B, right? Fewer errors has to be better. But is it really that simple? Of course not. It's a trick question. We have absolutely no way of answering that because we're missing context. What if Team A built a massive 1 million line system and Team B built a tiny little app? All of a sudden, 342 errors might look pretty amazing. To make a fair comparison, we have to normalize the data. So, how do we do that? How do we normalize? Well, normalization is just the fancy word for adjusting our raw numbers so we can create a level playing field. And in the software world, there are 2 main ways we do this. The first way is size-oriented, and it's usually based on lines of code, or LOC. It's super easy to count, but it's also kind of flawed. 100 lines of a modern language like Python could do the same work as 1,000 lines of something older. The other way is function-oriented, which tries to measure the actual functionality the software delivers to the user. This is a much fairer comparison, but yeah, it's a lot harder to calculate.
That function-oriented approach leads us to this thing called function points. Now, don't worry, we're not going to do all the math, but at a really high level, it's a 5-step process. You count a bunch of key parameters, figure out how complex they are, get a raw number, tweak it based on overall system complexity, and then you get your final adjusted function point count. So you're probably asking, what are we even counting? Well, it's things the user can actually see and interact with. The number of screens where they can input data, the number of reports the system can spit out, the number of different questions a user can ask. This is our best shot at putting a hard number on something as fuzzy as functionality.
Okay, so we've covered the why, the what, and the how. But here's the thing, just because you can measure something doesn't mean you should. Not all metrics are created equal. So what separates a truly great metric from one that's just a waste of time? Think of this as your essential checklist. A good metric has to be simple and objective, no room for interpretation. It has to be pretty easy to get, otherwise, let's be honest, nobody's gonna bother. And this is the most important one, it has to be valid. It has to actually measure the thing you care about. If your productivity metric encourages developers to write thousands of lines of sloppy, useless code just to pump up their numbers, well, that's not a valid metric.
And that kind of brings us to our final thought for today. These principles, they've been the foundation of software measurement for decades. But now, we're entering a world where AI tools are writing more and more of our code. So how will our metrics have to change? When a developer can prompt an AI to generate thousands of lines of code in a single minute, what does lines of code per person month even mean anymore? How are we going to define quality and productivity in this new world? That's a question we're all going to have to answer, and soon.